Science, please!
Planets, people, pussycats. In fact, nothing in the universe would exist if it wasn't for the atom! Atoms are itsy-bitsy, teeny-tiny microscopic particles. One speck of dust contains thousands of billions of atoms. Can you imagine how many atoms there are in this spiffy vacuum cleaner? An atom is made up of a nucleus with a positive electrical charge and negatively charged electrons. If the nucleus of the atom were the size of a raspberry, the orbit of its electrons would be as big as the Titanic. Only 92 kinds of atoms make up all the substances that exist. For example, gold is made up of atoms of gold. Atoms of hydrogen and oxygen combine to make water. If we didn't have atoms, there wouldn't be any clothes or any girls. What a shame.
Science, please!
Water is wet, but it isn't always a liquid. Depending on its temperature, water, like lots of other stuff, can be a solid, a liquid, or a gas.
And that's the state of the matter!
Ice is water in its solid state. Strong bonds keep the water molecules in an organized structure. When you heat up the molecules by adding energy, they start to move. Their bonds break and reform continuously, and water changes from a solid to a liquid state.
If we heat it up even more, the molecules break free and zoom away from each other. Water turns into a gas. But it works
The other way, too. If you remove energy from water by cooling it down, it becomes a solid again.
My tongue's stuck.
Oh, like the more energy, like the less stable the matter, dude.
Science, please!
Life can be a low-down, dirty business, especially when you have to wash with soap. Why soap? I'll tell you why in The Dirt on Soap!
Soap has a split personality. The head of the soap molecule is made of an alkali, and its body is made of fat. Yes, fat. Dirt is also made of fat. Water and fat don't mix. But when you wash, the fat in the soap grabs onto the fat in the dirt, and its alkaline part sticks to the water. So soap forms a link between the water and the dirt and removes it. Next thing you know, you're clean.
Science, please!
This is a bomb. Kaboom! And this is another bomb. You'll see why in explosives. Explosives are very powerful and very dangerous, so they need to be handled with care. An explosive is a material which, when subjected to a little bit of heat, converts to a humongous amount of super hot gas. This mass of gas can exert pressure of up to 500 tons per square centimeter. It's this enormous pressure that causes the explosion. Many substances are explosive. When methane mixes with oxygen, you get a violent conflagration. There's methane in natural gas and in the intestinal fermentation of cattle. That's why, oh, look out! Just 'cause you're upside down, it doesn't follow that you'll fall. There's a force of attraction that keeps your feet firmly on the earth. An object in space is attracted to the ground by this same force. The force is called gravity. The law of gravity states that all bodies are attracted to one another. When you jump, gravity slows you down and speeds up your crash landing. The greater a body's mass, the stronger its gravitational pull. The moon has a smaller mass than the Earth, so gravity on the moon is weaker. Everything there is 6 times lighter. As objects move further away from each other, the pull of gravity decreases, till eventually we float away.
Science, please!
Muscles are great for impressing your friends or settling your differences. But when brute force isn't enough, you can use your head. And an amazing tool as demonstrated in Operation Lever.
There are levers everywhere, cleverly disguised. They work on a simple principle.
Yeah, a rigid bar pivots on a fulcrum.
When the part of the lever where the force is applied is twice as long as the part bearing the load, the power is multiplied by 2. If it's 5 times as long, the power is multiplied by 5. Levers always transform a little effort into a large force. You don't have to be as strong as an ox. Just use a lever. It's a jewel of a tool.
If you've ever had a bath, you will know that a body immersed in water displaces a certain amount of water. This was discovered by Archimedes, a learned gentleman of ancient Greece.
Eureka!
But why do some things float while other things sink? It's all because of the force of water.
A solid chunk of steel weighing 2 tons displaces very little water. It sinks. Whereas a 2-ton steel-hulled ship, by its shape, displaces a large amount of water. And the more water an object displaces, the greater the force of the water pushing against it. And it's the pushing up that makes the object float. So an object will float if the weight of the water it displaces is equal to its own weight. Archimedes sums it all up in Archimedes' principle.
Science, please. There are any number of ways to get off the ground. But over time, rockets emerged as the most efficient way to explore space. But how do rockets lift off? Isaac Newton's third law states,
For every action, there's an equal and opposite reaction.
the cannon fires, action, reaction, it recoils.
When the action's continuous, the reaction is too. The balloon will whiz around until all the air inside has been expelled. A rocket is propelled like a balloon. At liftoff, the ejection of burning gases generates enormous thrust. In reaction to the thrust, the rocket takes to the sky.
Houston, we have liftoff.
Research continues.
Science, please! Humans love to be on the move. But friction slows movement down.
What a drag!
Wheel meets friction. The battle is about to begin.
We lose a lot of energy dragging things over the ground. Even smooth surfaces are on a microscopic level rough. To eliminate the friction of dragging, we put rollers underneath whatever we want to move. Add an axle, and you've got the wheel. No more friction. You're really on a roll.
Well, not quite. There's still some friction between the wheel and the axle. Will friction have the last word? No. By putting little balls between the wheel and the axle, we eliminate friction once again. We've just invented ball bearings and reinvented the wheel. It's another victory for humanity!
Science, please!
Do the words auto mechanics make you curious? Actually, it's a cinch. A car is made up of wheels, seats, fuzzy dice, a body, and an engine. The internal combustion engine. The engine works in 4 stages. First, a valve opens and the piston lowers, letting a mixture of fuel and air into the combustion chamber. Second, as it comes up, the piston compresses the fuel-air mixture. Third, a spark from the spark plug ignites the mixture, which pushes the piston down again. Fourth, the exhaust valve opens and as it comes up, the piston pushes the spent gases out. And the cycle starts over again. Intake, compression, combustion, exhaust. Intake, compression, combustion, exhaust. Intake, compression, combustion, exhaust. Intake, compression, combustion, exhaust. The movement of the engine is transmitted to the wheels for the driver's delight.
Science, please!
Fire is a chemical reaction that produces light and heat. This reaction occurs between something that can burn and the oxygen in the air.
At the molecular level, wood, like all other things that can burn, contains carbon and hydrogen. To make fire, you have to provide a little heat to the wood. This heat breaks the bonds between the carbon and the hydrogen. Once they're free, the carbon and hydrogen create new bonds with the oxygen in the air. This chemical reaction produces a lot of heat. This heat breaks more carbon-hydrogen bonds. New bonds are formed and produce even more heat and fire. Fire!
Say fire? Where?
Fire causes a lot of damage, but human ingenuity has harnessed its power to toast tasty marshmallows. Yum.
Science, please! From the dawn of time, the wind has blown across the face of the earth, messing up pretty ladies' hairdos. Is this a mystery? Find out in The Wind!
Our team of world-famous scientists has developed sophisticated instruments, enabling them to observe the behavior of air at the molecular level.
Air is composed of molecules of different gases. When the air is cool, the molecules huddle together. Warmed by the sun, they become more active and scattered, making the air less dense and consequently lighter. The molecules therefore rise. Other molecules rush in to take their place. They too warm up, rise, and are replaced. An air movement is created. It is the wind! Science, please! Ice has many uses. Ice is good for cooling off, freezing meat, or going for a spin. Ice is slippery, but why? Is it smooth? No, not all smooth surfaces are slippery.
At the microscopic level, smooth surfaces actually appear very rough. If you slide a skate blade over a board, these mountains and valleys fit into each other, locking together like Velcro.
Ice, on the other hand, is slippery because a thin layer of water acts as a lubricant, reducing the contact between the ice and the skate blade. So, it's water that makes ice slippery. With the inevitable results. Science, please!
It's no fun being cold.
Unless you're a roasted beef.
In that case, you belong in the refrigerator.
A fridge produces cold because a compressor, a motorized pump, circulates a cooling liquid, a refrigerant, through a bunch of pipes. When it comes into the fridge, the refrigerant is a liquid, but it quickly transforms into a gas by absorbing the heat that's in the fridge. That's what makes it cold. Then, the gas is sucked out by the compressor and pumped to the outside of the fridge, where it releases its heat and becomes a liquid again. And the cycle continues.
Without a fridge to keep leftovers in, we'd have to clean our plates at every meal or dispose of the food in secret. The fridge keeps everything we put in it nice and fresh.
Boo. Super cool.